Hey physicists, this is going to cover material from 1.2 distance and time, making graphs, and 1.3 speed. We're going to put those together so we actually make a speed graph. Let's go with a little review of our position versus time. Okay, have our running man down here running toward the checkered flag, and at even time intervals 2, 4, 6, 8 seconds and so on, we're checking his position. So our independent variables when I choose to make the measurement, and the dependent is I measure the distance. So we want to create a graph. Okay, go ahead and put our time along the independent or x-axis, the horizontal axis. Notice I have one division per, 1 second per division. Our vertical or dependent axis is our position in meters. This one I looked at my maximum value, 36 meters, and I had to fit it onto my scale. So I came up with 5 meters per division, okay, and I title a graph position versus time. Let's go ahead and plot each of these positions. 0 seconds and 0 position. Next one is 2 seconds and at 1 position. 4 seconds and 4 meters. Okay, 6 and 9 meters. At 8 seconds we're at 16 meters. At 10 seconds we're at 25 meters, and finally we're at 36 meters at 12 seconds. Let's draw a smooth line through there. And that gives you your position versus time graph. Hey, let's take a look at speed. 1.3 presented speed as being velocity or speed. Remember, velocity is just speed with distance. Speed with direction is our distance d divided by time. And remember, this will be the distance since our last measurement and the time since our last measurement. We're looking at intervals. In this case, we traveled 36 meters in 12 seconds, so our average speed was 3 meters. But we can see that really doesn't represent our movement very well. We started off going very slowly. We only traveled 1 meter during the first 2 seconds, and toward the end we were moving along quite quickly. We covered 11 meters in the last 2 seconds. There's probably a better way of representing that. We're going to take advantage of the idea of making a graph. Again, we'll look at time as our independent variable, okay, and we'll look at velocity as our dependent variable. Let's go through the calculations. Remember that we can calculate velocity is our distance traveled over time over our entire experiment or any particular interval that we want to. So let's go ahead and take a look at that. Okay, so from a time of 0 to a time of 2, we moved 1 meters. It took us 2 seconds to do that. If I do my calculation of distance divided by time, I realize my average velocity during that first 2 seconds was half a meter per second. Let's take a look at the next interval. I went from 1 meter to 4 meters. That was a distance of 3 meters, and that took me 2 seconds. So over that interval, my average speed was 1.5 seconds. Another way we can think of that is my current position is 4 meters. I subtract 1 meter, my starting position at that time interval, and I get 3. Let's go ahead and fill out the rest of that table. And we can see something that better represents our motion, that we started moving slowly, went faster and faster and faster and faster. Again, we have to cover at least 5.5 meters per second. Look at the units, meters per second on our graph here. And we ended up going with half a meter per second per division. Let's go ahead and plot those. At 2 seconds, we were going 0.5 meters per second. At 4 seconds, we were going at 1.5 meters per second. At 6 seconds, we were traveling 2.5. Again, at 8, 10, and 12. This better represents what our motion, our speed, or our velocity was. It started very slow and then sped up with time. Once we got to this point, let's put a smooth line through the points. Okay. We're going to start looking at a different type of motion. We're starting at the origin, moving to the end, staying there for a while, and then heading back toward our original position. Want to make a graph of that? We'll start off with our independent variable, time, along the horizontal axis, our dependent variable, position, along the vertical axis, and we'll title this graph, and we'll put our points along the graph. We see a point at 0 seconds at 0 position, at 2 seconds at 4 meters, at 4 seconds at 8 meters, 6 seconds at 10 meters, and again another position at 8 seconds at 10 meters. At 10 seconds, we're going back toward our starting point. We're at 6 meters, and at 12 seconds, we're at 2 meters when we finish up. Let's go ahead and put a line through that to represent the motion. Now we'd like to take a look at what our average velocity is. Again, it's our distance traveled in the time it takes us. If we look at where we start and where we finish up, we start at 0, we finish off at 2, and it takes us 12 seconds. If I looked at that, I would say my average velocity, or my speed, was 0.17 meters per second. But there's a better way of indicating that motion. So again, let's go ahead and calculate our velocity at each of those time intervals. Our first time interval, we don't get a velocity measure because we have to look at how much we've moved. So the first point, we don't have one yet. So let's take a look at our second position. We've moved from a position of 0 to a position of 4. So 4 meters. How long did it take us? 2 seconds. I take my distance traveled divided by my time. I get 2 meters per second. Let's take a look at the next unit. We again traveled 4 meters in 2 seconds. We're again at 2 meters per second. Now let's take a look at the rest of this chart. Okay. When we get to this at 8 seconds, how far have we gone? We haven't moved at all because our position remains the same, yet 2 seconds have gone by. The distance I traveled, 0 meters. In 2 seconds, my velocity during that time is 0 meters per second. Let's take a look beyond that. We actually start going backward. And this is where the idea of velocity starts becoming important. We're looking at not just how fast we're changing our position, but what direction. So we went from 10 to 6. We've gone minus 4 meters. We've gone backward 4 meters. It took us 2 seconds. So our average speed is minus 2 meters per second. Let's go ahead and graph that. Again, our velocity is going to be our dependent variable because our velocity is dependent on how much time has gone by. And we'll start plotting our points here. Okay, we started off at 2 meters per second. Again, we were at 2 meters per second. We slowed down to 1 meter per second here. Then we got to the point where we actually stopped for a short period of time. We see that we're at 0 meters per second. Something a little different here is this curve has both, or this graph has both a positive portion and a negative portion. Our next point is we're at minus 2 meters per second. And again, we finish off at minus 2 meters per second. Let's go ahead and fit a line through all those to see what our motion looked like. So looking at these graphs, I could say from the position versus time, as time went on, I got further away from my starting point, stopped for a little while, and then moved back toward my starting point. What is the velocity curve, or the story that tells us? I was moving forward, slowed down, came to a stop, and then started moving backward, and then kept moving backward at a constant velocity. So this is putting together sections 1.2, distance, time, and graphing, and 1.3, speed. So now we are able to do speed versus time graphs.